Hello, and welcome to the first video of a series of videos on how to go about finding exoplanets. In this video, we will be covering what are exoplanets and as well as how they are found. Exoplanets have only been recently discovered as early as 1992, with the first method of finding one being of pulsar timing. Since the first detection of the two exoplanets, the number of detections have dramatically increased. My name is Kyle Lynch. I am an amateur astronomer and an active exoplanet hunter. I have been searching for exoplanets for almost 5 to 6 years now. There are multiple ways of detecting and characterizing exoplanets, but first, what are exoplanets in general? Exoplanets is actually two words into one. Exo meaning outside our solar system, and planet an object that could be defined as a celestial object that has enough mass to be around and has cleared its orbit of smaller objects. What methods are out there that are currently available to detect these types of objects? We will go over 3 methods that have been used to detect exoplanets, such as the transit method, radial velocity, and astrometry. The transit method is the foundation and most successful way of spotting an exoplanet by measuring the relative brightness of a star over a certain amount of time. If that brightness varies the same depth and shape, we can assume something is orbiting the star. In all cases, the shape of the curve is usually a U-shape versus a V-shaped curve, which in another video I will cover. When an exoplanet is spotted by ground-based or space-based photometry like Kepler or TESS, it is usually undergoing a rigorous follow-up campaign to confirm its planetary origin, using not just the transit method. Radial velocity is another method that is sometimes used in conjunction with the transit method. The radial velocity measures the wobble of the star based on redshift or blue shift. If a star is redshifted, it is moving away from you. If a star is blue shifted, it is moving towards you. If the wobble is occurring at the same rate, we can assume something is orbiting the star. This method could give us estimated eccentricity, orbital period, and orbital inclination dependent to the observer location. The next method is called astrometry. Astrometry measures the precise shift in the star's orbit like the radial velocity method over time to detect a wobble. This method works for large planets in longer period orbits around their host stars. I hope to see you guys in the next video, where I will be talking about how to detect an exoplanet via the transit method in more detail. Until then, see you next time.